Happy morning, everyone. Dear student, we are learning chapter Wave Optics. In this chapter, we have already discussed corpuscles nature of light, wave nature of light, then primary and secondary sources, wavefront, types of wavefront, then Huygens principle, then progress of a plane wavefront according to the Huygens principle, progress of a spherical wavefront according to the Huygens principle. Then what is the Huygens principle? Huygens is the name of the scientist. According to the Huygens, every point on a wavefront acts as a secondary source of a light. Therefore, it emits the secondary waves or secondary wavelets, and envelope of all these secondary wavelets form a new wavefront. This is the Huygens principle. Simple, because if there is a primary source, this primary sources produces the spherical wavefront. Okay, then point on the spherical wavefront acts as a secondary sources. Okay, so suppose this is the primary source is S1 and this is the secondary source S2. Therefore, it emits the secondary waves or secondary wavelets, and envelope of all these secondary wavelets form a new wavefront. This is the new wavefront. This is called as a Huygens principle. Okay, then according to the Huygens principle, in this lecture, we have to discuss the laws of reflection of light at a plane surface. Okay, therefore, consider AB is the plane wavefront. What is the AB? AB is the incident plane wavefront. Okay, this plane wavefront, you know that plane wavefront is indicated by the parallel lines. Therefore, this is AB. This AB is the plane wavefront, which is bounded by the rays RA and QB. Okay, it is incident on the reflecting surface called as a MN. What is the MN? MN is the reflecting surface, say the mirror. Okay, now this is the incident wavefront AB touches the reflecting surface at A at time t is equal to 0. ओके, इथं जो काही वेवफ्रंट आहे हा ए बी वेवफ्रंट, तो इथं ए या पॉइंटला पहिल्यांदा काय होणार आहे, टच होणार आहे व्हेन टाइम टी इज इक्वल टू द 0. Okay, when the time t is equal to 0, the incident wavefront AB touches the reflecting surface. Then the point B will touch the reflecting surface at point C at the same time. Okay, मग ज्यावेळेस t is equal to 0 असेल त्यावेळेस इन्सिडेंट वेवफ्रंट ए या पॉइंटला टच होणार आहे, परंतु बी टू सी एवढं डिस्टन्स कव्हर होण्यासाठी काहीतरी वेळ लागणार आहे, आणि तो वेळ आपण काय म्हणूया, स्मॉल टी इज इक्वल टू द कॅपिटल टी. देअरफॉर द पॉइंट बी will touch the reflecting surface at C after the time small t is equal to the capital T. Therefore, between the time t is equal to 0 and small t is equal to the capital T, between the time t is equal to 0 and capital T, different points along the incident wavefront reach the reflecting surface successively. या टाइम मध्ये t is equal to 0 तो t is equal to capital T, या टाईममध्ये डिफरंट पॉईंट्स अलॉंग द इन्सिडेंट वेव्ह फ्रंट reach the reflecting surface successively and secondary waves will produce. Secondary waves म्हणा किंवा secondary wavelets will produce in the same medium. याच मीडियममध्ये मग ते एअर मीडियम असेल. ओके, याच मीडियममध्ये काय होणार आहे, सेकंडरी वेव्ज ह्या तयार होणार आहे. कारण ए काय होणार आहे, हा सेकंडरी सोर्स म्हणून ऍक्ट होणार आहे. सी सुद्धा काय म्हणून ऍक्ट होणार आहे, सेकंडरी सोर्स म्हणून ऍक्ट होणार आहे. आणि देअरफॉर ॲज सून ॲज द इन्सिडेंट वेव्ह फ्रंट ए बी टचेस द पॉइंट ए, इट विल प्रोड्यूस द सेकंडरी वेव्ज इन द सेम मीडियम. ओके, इन द फॉर्म ऑफ ए हेमिस्पियर. हेमिस्पियरने ते आपण दाखवलेला सुद्धा आहे. व्हॉट इज द दिस एई, दिस बी सी. ह्या एई आणि बी सी काय डिनोट करतात आहे, तर एई अँड बी सी डिनोट्स द रिफ्लेक्टेड वेव्ह फ्रंट. देन यू नो दॅट फॉर रिफ्लेक्शन द हेमिस्पियर टू बी कन्सिडर्ड आर ऑन द सेम साइड ऑफ द मिरर. हेमिस्पियर जे काही प्रोड्यूस होणार आहे ते मिररच्या सेम साईडला काय होणार आहे, तर प्रोड्यूस हे होणार आहे. द वेवलेट इमिटेड बाय पॉइंट ए विल हॅव द रॅडियस व्ही टी ॲट टाइम टी. जी काही रॅडियस आहे कशाची, द सेकंडरी वेव्हची, की ज्या ए पासून प्रोड्यूस झालेला आहे ए ई, ही जी काही रॅडियस असणार आहे विच इज इक्वल टू द व्ही टी. व्हॉट इज ए ई, ए ई इज इक्वल टू द व्ही टी. This is the radius of a hemisphere. Okay. Then the radius of the wavelets emitted between the points A and C will decrease from Vt to 0. नंतर ती radius काय होणार आहे, इथं पहा, इथं A असणार आहे, परंतु इथं आल्यानंतर C या पॉइंटला आल्यानंतर radius ऑफकोर्स काय होणार आहे, डिक्रीज होणार आहे. Okay, and the envelope of all these wavefront form a reflected wavefront. Okay, then this reflected wavefront is denoted by EC. What is the EC here? EC is equal to the reflected wavefront. Okay, AB is the plane wavefront and EC is the reflected wavefront. It is denoted by the EC. And it is drawn by tangent to the hemisphere. Reflected wavefront कसा काढायचा आहे, तर tangent to the hemisphere. बरोबर इथं जो काय अँगल झालेला आहे ईला तो किती असणार आहे, तर 90 डिग्री असणार आहे. ओके, आणि देन कन्सिडर द जॉमेट्री ऑफ द फिगर. सी द टू ट्रायंगल ए बी सी अँड सेकंड वन इज नथिंग बट ए ई सी. फर्स्ट ट्रायंगल इज triangle A B C and second one triangle is triangle A E C. Okay, in this triangle what is the AE? What is AE? See this, AE is equal to the VT. AE is equal to the VT. What is the AE? AE is equal to the VT and which is equal to the BC. BC. BC आणि AE हे काय आहे, तर रॅडियस ऑफ द हेमिस्पियर आहे. ओके, त्यांची जी काही व्हॅल्यूज असणार आहे ती किती असणार आहे, VT असणार आहे. वेअर V इज अ व्हेलॉसिटी अँड T इज द टाइम. म्हणजे त्या वेव्हजला तेवढं अंतर काटण्यासाठी, AE अंतर काटण्यासाठी लागणारा वेळ इज नथिंग बट ए टाइम T. Therefore in these two triangles AE is equal to the VT is equal to the BC. Okay, then we can say that AC is equal to the CA. Means it is common. We can say that AC ही दोन्ही ट्रायंगलला काय आहे, it is the common. Okay, now the triangle ABC and AEC. See this triangle ABC and triangle AEC are, yes, what is its value? See this, A, B, C, it is 90 degree. Next, A, E, C, it is again the 90 degree. Therefore, these two triangles are the equal triangles. Okay, two sides are equal. Then these triangles are equal we can say that it is 90 degree. Therefore, both the triangles are the congruent triangles. Therefore, we can say that angle, see this, it is important one, BAC is equal to the angle ECA. See this. Therefore, angle BAC. Where is angle BAC? BAC, which is equal to the angle ECA. Okay, because these two triangles are the congruent triangles. Okay, triangle ABC and triangle AEC are the congruent, and therefore this angle BAC is equal to the angle ECA. What is the angle BAC from the figure? See this, BAC, it is nothing but a I. It is the I, angle I. What is the angle EAC? This is EAC. It is nothing but a R. Okay, it is R. Sorry, ECA is R. Therefore, this is the law of reflection. Angle I is equal to the angle R. What is the angle I? I is the angle of incident, because this is PA is the normal. The angle between normal and incident ray PA is called as a angle of incident. Okay, and angle between the reflected ray and normal is called as a angle of reflection R. Therefore, this is the laws of reflection. Angle of incidence is equal to the angle of reflection. Again, the incident rays, normal and reflected rays lies in the same plane. This is the second law of reflection. Then third law is incident ray and reflected ray lie on the opposite side of normal. Okay, all these are the laws of laws of reflection. How it is explained? First statement, how it is stated. First one is angle of incidence is equal to angle of reflection. Then incident rays, normal and reflected rays lie in the same plane. Then incident ray and reflected ray lie on the opposite side of the normal. Okay, this is the laws of reflection on the basis of Hygiene's principle. Question on this concept is explain the laws of reflection at a plane surface using the Hygiene's principle. Then you have to draw this net label diagram and we have to write the description of this ray diagram, okay, in your language, and you have to write these mathematical steps or geometry from the figure. Okay, let us stop here.